Okay, guys, pretty short one here for you today. We are talking about histograms. Okay, guys, pretty short one for you here today. Our third lesson in chapter 5 is on histograms. Now, a histogram is almost exactly like a bar graph. The only difference is that it's used to represent data that is continuous, so the bars are touching. Now, if you remember back to our bar graphs, we had data that was discrete, which means that we have individual points that we plot. With continuous data, it's like a continuation between the points. So, like if we were drawing a line graph, we could connect the lines. But with a histogram, it's essentially a bar graph for continuous data. So the width of each bar represents kind of like a range of numbers. And so what we'll get for our data is we'll get like a certain range of numbers that we have to, you know, uh, we have to incorporate into our graph. I'll give you an example of what I mean here. So here in this first example, the histogram below shows the number of airplanes scheduled to arrive at the Calgary International Airport on a particular day. So if we look at the graph, first of all, the title, number of arrivals scheduled at the Calgary International Airport. You can see the graph immediately. It's a bar graph, but the bars are touching each other, right? There's no space in between there. And so this is actually not just a bar graph, it's called a histogram. And something that's important about this specific histogram, well, if we look at the y-axis, this is the number of airplanes scheduled to land, all from 0 to 12, and we're going up by 1. Each dash is worth 1, but we've only labeled every second dash. And then on the x-axis, we have the time, and the time is an interval. So the first interval of time is from 000, which in military time, in the military clock, it's midnight. That's 12 o'clock midnight to 600 or 0600, which is 6 o'clock in the morning. So this is 6 a.m. So our first interval is from midnight to 6 a.m., and we have 2 planes scheduled to land. The second interval is from 6 a.m. to 7 a.m., and we have 3 planes scheduled to land. The third interval from 7 a.m. to 8 a.m., again, we have 2 planes scheduled to land, and so on. We can see our data. So the difference, I hope you can see the difference here. On my x-axis, it's an interval. An interval. So it represents a grouping of, in this case, time. And notice that our first interval is 6 hours long, but because we only have 2 planes to scheduled to land between those hours, it's okay. We can have a 6-hour interval here, and then we have an hour-long interval kind of continuing on through the remainder of the day. So here we go. Here are some questions we'd be expected to answer for this. So A says, how many airplanes are scheduled to arrive between 2 p.m. and 3 p.m.? Okay, 2 p.m. in military time. Essentially, what you can do for military time, if you want to figure it out, you take like 2 o'clock p.m. and you can add 12 hours to it. So if we add 12 to 2 p.m., we actually get to 14, right? If we take the 2 and the 12 and we add them together, we get to 14. So we'd be at 1400 hours. So 2 o'clock is 1400, and 3 o'clock for the same reason is 1500. So here's my interval. Between 2 o'clock and 3 o'clock, this is my data point. There are 4 planes scheduled to land. B says, what are the busiest times at the airport? And how many airplanes are scheduled to arrive at these times? Well, the busiest times would be when I have the most planes scheduled to land, of course. And so the most planes scheduled to land, I've got one section here, one section here, and one section here. So the first one is between 11 o'clock and 12 o'clock. So 11, whoops, not 10, but 11 o'clock and 12 o'clock, or 11 and 1200 hours. And there are 10 airplanes scheduled to land. The next interval, 1500 and 1600. Well, to figure out what time that is, again, the same logic. I'll take 1500 and subtract 12 hours now to get my non-military time. So 15 minus 12 is 3. So it's 3 o'clock, and it's PM. So between 1500 and 1600 is 3 o'clock and 4 o'clock PM. And there are 10 airplanes. And last but not least, between 1700 and 1800, you could answer it as 1700 to 1800 as well. And there are 10 airplanes. Excuse my writing. It's really, really bad today. But C says, what is the quietest time? Well, some people might get confused on this question because, if you look at the intervals that have the lowest amount of airplanes that are landing, so here there's only 2, here there are 2, here there are 2, and here there are 2. That's 4 different times. However, the average amount of planes that are landing in that section of time between 0 and 600 hours, 0600 hours, the average is way, way down. So I would say that the quietest time is between 000 and 0600 hours. And D says, are any airplanes scheduled to arrive between 4 a.m. and 5 a.m.? Well, we just kind of talked about that section of time. We don't know specifically if they're going to land between 4 and 5. We know they're going to land between midnight and 6 a.m. So the answer is there could be 2 planes. However, we are not sure. Okay, so I hope a question like that makes sense. The biggest difference here, guys, is that it's a histogram. And a histogram, you connect your bar graph, and you connect them because you have an interval of time that you are going between, or an interval of data. It might not necessarily be time, but in this case, it is time. Okay. I hope that makes sense. I'll send one more example your way.